Hi everybody, my name is Jordan. I'm an application engineer, as Chris mentioned, out of our Oregon office. And today what I'm going to be sharing with you is a quick webcast on weldments. So there's a few tips and tricks in here. There's actually quite a few tips and tricks in here. The way I'm going to structure the webcast today is I've broken it down into 3 main topics. And throughout those 3 main topics, we're going to cover a wide range of weldment techniques as well as a bunch of tips and tricks in there. So let's go ahead and get started, and I'll kind of break down the roadmap of what the webcast is going to look like today. So the first thing that the first slide I have here is if you don't hear anything, if you have any audio issues, switch to a phone and call in. There is a phone number available when we first got started. It's also in the chat there if you can see it. So if you can't hear me, just go ahead and call in. So the way I'm going to break down the topics for today is I have a little bit of what I call something for everyone. And what I mean by that is I have a beginner tip, an intermediate level tip, and what I consider an advanced tip. So the way I'm going to break these down is for my beginner topic, I'm going to talk about 2D sketching versus 3D sketching. So for my intermediate tip, we'll then go into creating our own custom weldment profiles. And then lastly, for my advanced tip, I'm going to talk about non-standard, or in this case, a very specific curved miter. So if you don't have a clean 45-degree miter or anything that's considered non-standard, I'll show you how we can approach those with some different techniques. So let's go ahead and start with our beginner tip, 2D sketching versus 3D sketching. And the way I'm going to introduce this is I'm going to create something that should be fairly common. I'm just going to create a 3-dimensional cube. And not so much the cube, but think of it as a wireframe cube. So in this case, what I'm going to do is make this cube using 2D sketching, and then I'm going to make the exact same cube in 3D sketching, and then we can see the differences. So the main difference when we consider 2D sketching, you have to choose a plane, so you're confined to 2 dimensions. In this case, we are on the XZ plane. And what I'm going to be doing is making a 1 foot by 1 foot by 1 foot cube. So there's 12 inches by 12 inches, and there's my first sketch. So using just 2D sketches, if I want to create a 3D plane, what I'm going to have to do is create my own reference planes. And here's one of those tips that's going to appear really early. If you want to create an offset plane really easily, hold down the Control key and drag one of the planes that already exist, and it's going to jump you into an offset plane. So in this case, I'm going to create the top plane of my cube because I'm confined to 2D sketches currently. So I'm going to create a 12-inch offset, and then I will sketch on that plane. And I could redraw the top of the cube if I want, or if I want to reuse geometry, I can just select the sketch and use Convert Entities. So there is the top of my cube. So now what I'm going to have to do with 2D sketches, I'm going to have to complete the legs of my cube. So in this case, what I'm going to do is leverage those planes again, and I'm going to create an offset plane at the front, and I'll do the back of my cube as well. So I'm just using a point as a reference for my offset plane, and then I can sketch on those planes that I've just created and create the legs of my cube. So this is all being done using 2D sketches. So 2D sketches require a plane. You have to be locked in 2 dimensions if you're going to be using a 2D sketch. But you can see creating 3D objects, or in this case a wireframe of a 3D object, is still possible using 2D sketches. But if we're confined to 2D sketches for this cube, which I can see is a nice 3-dimensional cube, I had to create 3 reference planes and 4 separate sketches. So there was a lot of work contained into creating that, completely possible in SOLIDWORKS, but a little bit of work. So in that case, what I'm going to introduce is the idea of 3D sketching. How can we put all of that information all in one place, all in one sketch, so one single sketch, but all of the information for that cube is going to be contained in that single 3D sketch. So I'm going to jump back into SOLIDWORKS, and what I'm going to do is start a brand new part. Now, the first thing to note with 3D sketches is on your sketch command bar, where you're going to find the 3D sketch is under the drop-down for your sketch. So you will see 2D sketch and then 3D sketch. So the difficulties when getting started using 3D sketches, I'm going to go ahead and create my 3D sketch, is notice I didn't have to choose a plane. I'm not locked in 2 dimensions anymore. I am free to sketch in any dimension that I want now. Now that's a good thing and a bad thing. It's a good thing because I can sketch wherever I want, but it's a bad thing because it's kind of hard to tell where you are in space. So what I'm going to do is just take my first crack at drawing this 3D cube in 3D space, because all of my information is all in my 3D sketch, and I'm going to do my best to just kind of match it up. I'm going a little quick on purpose here, not trying to get it perfect, just to show you how easy it is to kind of get lost in 3D space. So there's my 3D cube, right? Well, let's rotate around a bit and see that things can be a little bit deceiving when you're in 3D sketches. And so this is probably the hardest thing to get over when you start using 3D sketches versus 2D sketches, is you have a lot of freedom in what you're making, but it's hard to keep track of where you are in 3D space. So there's a very specific way to approach 3D sketching in SOLIDWORKS, and I'm going to go back to an isometric here, and that is to pay attention to your mouse feedback. So I'm going to go back into my line command. Now we'll see with the mouse feedback, what I mean by that is the icon of my mouse. Currently my pencil is telling me I'm in a sketch line, but I've also got an XY below it. What that means is I'm currently sketching on the XY plane, or at least it's snapping to that plane. And if you want to toggle between different planes, you hit the tab key. So if I hit the tab key, you'll see it switches to YZ, so I'm now snapping to my YZ plane. And then if I hit tab one more time, there's my ZX plane. So right now I'm currently snapped to my ZX plane, so I have access to all of my current sketch commands. So let's go ahead and start that cube a little bit slower this time. So I'm going to start with my center rectangle again. So you have access to all of the sketch tools that you had in your traditional 2D sketch while you're in your 3D sketch. And since I am now currently on my ZX plane, you can kind of consider this my top plane. So I'm going to start at the origin, and you'll notice it'll create that corner rectangle as if I was on the ZX plane. So now what I can do is I'm still in my 3D sketch, no need to back out of the sketch and go back into it. I can jump into a line command, and now what I want to do is draw the legs of my cube. And if I'm going to go straight up, I need to make sure that the y-axis is one of my current planes that I'm sketching on. So ZX, I would not be able to draw a line straight up. So I'll hit the tab key and cycle to, in this case, XY. Since Y is one of the axes that I'm currently sketching on, I can then snap to my y-axis and draw that line straight up. So pay attention to that mouse feedback. It's going to make your life a lot easier in 3D sketches. Try to contain yourself to just 2 dimensions at a time, because if you're trying to do too much, it's a little bit easy to get lost in a 3D sketch. So in this case, I snapped 4 lines directly on the y-axis, and we also have access to our traditional relations in a 3D sketch as well. So if I wanted to control select both of these lines and make them equal, I can still do that in a 3D sketch. So I'll go ahead and select the rest of the lines also and make them equal. And you can start to see my 3D cube is taking shape in my 3D sketch. Now, one thing I'm missing is dimensions. So you can also dimension things in 3D space in your 3D sketch. So if I wanted to make sure my cube is 12 by 12 by 12, I can go ahead and add dimensions to different orientations. And the Smart Dimension tool is going to be able to tell what orientation will fit that dimension best. So because all of these are equal, I can go ahead and make this one 12 as well. And now all of my lines are in equal length. And then to finish it out, I can just connect the top portions of my sketch. Now, in this case, I don't have to be on my ZX plane. It would make my life easier. But in this case, you can snap to any points in 3D space, and SOLIDWORKS will still snap to those points. So I can still create those lines and snap to them. Or even if you're in the middle of a sketch command, notice I'm on my XY plane, you can always hit the tab key, and then you can see it cycling through the different orientations. So I'll go ahead and finish this out just by connecting the last few points. And now I've got my same 12 by 12 by 12 cube, but notice instead of creating 3 reference planes and 4 sketches, now everything is all contained in one single 3D sketch. So 3D sketches are very valuable because you can contain more information in them, but they are a little bit harder to use. So hopefully that at least introduces it so that the next time you ever need a 3D sketch, it's a little bit easier to catch on to. So now with that being shown in the 3D sketch that we just made, I'm going to show you a really quick way of making that. So even quicker than I showed with the 3D sketch. This is a technique you can use. It's a technique used specifically with weldments, and it's a way that you can capture the edges of a solid and then use those as your 3D sketch. So I'm going to create a brand new part. Like I said, I'm still aiming to create this cube, and I'm going to do this a little bit different than I did my last few cubes. So what I'm going to do is just create my 12 by 12 square, and then I'm just going to extrude this into my solid cube. So where I'm going here is I now have a solid cube, but you'll notice everywhere I have an edge on this cube is what I've been drawing manually in my 3D sketch. So it'd be nice if I could just extract those edges. And the answer, or a simple way to do that, is inside your 3D sketch, I can just take my edges and use the command convert entities to create my sketch. Now, it sure would be nice if I could just select all the edges right away. So that's where I'm going to introduce the last tip of this topic, and that is using sketch filters or selection filters. So, a question would be, would I be able to just selectively filter out the edges? And the answer is yes. So the way you're going to get to your selection filters is I'm going to introduce a couple hotkeys. So the F5 key, so function 5, F5 at the top of your keyboard, is going to bring up the selection filters toolbar. And with the selection filters toolbar, there's a lot of different filters you can use. They're kind of being cut off by the screen, but we have filter vertices, filter edges, filter faces. So in this case, what I want to choose is filter edges. And I'll show you the hotkey for this. The hotkey for this is E. And I'm going to turn on this filter edges. And now with the edges filter turned on, I'm just going to Windows select my solid, and it is just going to select all of the edges for me. Now, in this case, I didn't quite grab all of the edges behind the cube, so there's a few edges I couldn't see. So in this case, I'm going to use this in combination with a display filter and just turn it all wireframe. That way I can see all the edges, and now I can just graphically select all of my edges, and in one shot just say convert entities. So this is a technique used very commonly with weldments. I'm going to turn off my filter toolbar. If you ever see that pink funnel next to your cursor, that means you have filters turned on, so you may inadvertently turn on filters. So if you ever want to quickly turn those off, F6 will turn filters on and off. So F5 will show you the toolbar, F6 will toggle them on and off, as well as there's some hotkeys for point, edge, and face, and I'll show you what those are in a second on the slide. So if you ever do see that filter or that funnel, that means you have your filters turned on, F6 will turn those off. But now I've very quickly, just by creating the solid first, and I'll go back to shaded, we'll just hide the cube. I now have my 3D sketch with all of my edges. And like I said, this is a very common technique in weldments because a lot of times it's a lot quicker to sketch the solid, or maybe you have an enclosure. Just make it using a solid and then convert all those entities to your lines, and then you can use those lines as your weldment path for your 3D sketches. So 3D sketching, use the tab key when you cycle your planes. So look at your mouse feedback, make sure you're confining yourself to two axes at a time. It's a lot easier to keep straight when you're in 3D space, because if you just start sketching, it's really easy to get lost in the 3-axis space when you're sketching. And then here's all of those hotkeys. So F5 will show the toolbar, F6 will toggle them on and off, and then filter vertices, edges, and faces, the hotkeys for these by default are V, E, and X. And unfortunately, the X and V keys are very close to the space bar. So those are the ones most commonly hit inadvertently on accident when you're just trying to hit the space bar or something else on your keyboard. You may accidentally turn those on. So anytime you see that filter, that means you've got the filter hotkeys on, and you can easily turn those off. So that was my beginner topic. We're going to get a little more advanced here. For my intermediate topic, we're going to talk about creating your own custom profiles. So by default, SOLIDWORKS ships with or installs with some default profiles, but those profiles will only get you so far. So there's going to be times where you're going to have to go in there and create your own custom profiles. So before we go and create our own custom profiles, I kind of want to take a step back and let's understand what SOLIDWORKS comes with. So for me to be able to use weldments, I need to create a path first. And then on my Weldment's toolbar, and if you don't see this, just right-click and turn on your Weldment's tab on your command manager. And I'm going to invoke the structural member command, which will allow me to access my profiles. And if we look over here, the standard profiles, at the very least, you should have ANSI inch and ISO. So those are the ones that come by default. So if you need anything that's not contained in your ANSI inch or ISO libraries, you're probably going to have to create your own custom profiles. So we'll notice there's angle iron, C-channel pipe, a lot of common profiles in there, but it doesn't capture everything. Now, with that being said, there are a couple additional profiles included that don't get installed by default, and where you're going to find those is in your design library down here under SOLIDWORKS content. So under SOLIDWORKS content, there's a Weldments folder. There are some additional profiles in here that you can download. So if you hover over them, it'll say control-click to download the file. So there's a few different country standards in here. The ones you can utilize are ANSI inch and ISO. These are for Japan, Great Britain, Germany, things like that. So at the very least, you can grab ANSI inch and ISO, just control-click to download those. And then the second step, and probably the more important one, is you'll need to extract those profiles to the correct location. So where is the correct location for your Weldment profiles? So by default, and where you're going to find your profile location, your Weldment profiles location, is going to be in your system options. So go to your tools, options, and then under file locations, we will have a file location for your Weldment profiles. So this is the default location. I haven't changed it. It's in C Program Files, SOLIDWORKS Corp 2019. I did rename my folder. Yours may just say SOLIDWORKS Corp. And then SOLIDWORKS Lang English Weldment Profiles. So that's a pretty long path. If you ever want to find out where yours are saved, or if you have these on a server location or a different location on your hard drive, make sure you're pointed to the correct location that has your custom profiles. Or if you create custom profiles, make sure you save it in this location so that they will appear when you go to create your Weldments. So you can always check it in your system options. And if I open a folder, I've actually got mine pinned. So C Program Files, Corp, SOLIDWORKS Lang English Profiles. And you can see if we actually go to that location, the 4 categories that I had corresponded to these 4 folders. So it's just a folder structure for your Weldment profiles. Save them in here, and then you'll be able to access them. So let's go ahead and create our own Weldment profile now that we know where to save it. In this case, what I'm going to be doing, and I'll just create a brand new part here. I'll go ahead and close a couple so we don't get too many files open here. I'm just going to create a brand new part, and this is how you're going to create your custom profiles. Just create a brand new part. That's all you need. And what you're going to do is sketch the 2D profile of your Weldment profile. So in this case, any plane works. Front and right are probably the easiest way to think about it, but you can sketch on any plane for your profile. And in this case, the profile that I'm going to be making is a library that I think everyone should have, but doesn't come by default, and that's just structural lumber. So 2x4s, 2x6s, 2x8s. So it's a really easy one to create, and if you do any kind of woodworking, very valuable. It's going to save you a lot of time and great for using Weldments. So in this case, what I'm going to do is create my profile for a 2x4. Now, when I created it, notice I can add construction lines either from the corners or from my midpoints. I'm adding construction lines for my midpoints, and you can see the construction lines being added here. That's actually very valuable for my Weldment profile. And I'll show you where down the line that becomes useful for us. So anytime you're creating your profiles, keep the construction geometries in mind, because anywhere there is a point created by that construction geometry, you'll be able to use as a locator for your profile along your path. So I'm creating the profile for my 2x4, and I'm going to add a couple dimensions. I will make it actual dimensions for these. So 1.5 inches by 3.5 inches. So here is the profile for my 2x4. Now really, that's all I need. I can then save this as a profile. But I'm going to include a little bit more information in here because I want to be able to utilize multiple structural sizes in the same profile. So what I'm going to do is go to my configurations, and I'm going to rename this configuration 2x4, and I will create a new configuration called 2x6. So I'll have 2 different sizes in this profile, 2x4 and a 2x6. So for my 2x6, I want to make sure my 2x6 is the correct size, so I'm going to configure this dimension. Right-click and configure the dimension. It'll allow me to change that dimension for just the 2x6 configuration. I'll make it 5.5 inches. Apply and OK. And now with my configurations, I've got a 2x4 and a 2x6. So really, this is all I need to set up a profile. This is ready to be used as a Weldment profile. Now, this step is very critical when saving your custom profiles. We have to save it as a very specific type, and we have to save it in the right location. So we know where the right location is. It's in our options. But when you save it as your type, make sure you select the sketch that you want to be your profile first. So that's the important step. Select your sketch, and then do a save as. And the file type that we need to save it as is going to be called a library feature part, so SLD LFP. So that is the specific type that you're going to use whenever you create a Weldment profile. So we're going to change that type. It'll default to your design library location when you do that. We definitely want to save it in our Weldment profiles location though, so I've pinned it just so I can get to it easier. So we're going to put it in the correct location, and I'll just create a new category with a new folder called lumber. So I've got a new category called lumber, and inside that category I'm going to save my custom profile, and I'll call it something like softwood. So I've now got my softwood custom profile saved as a library feature part in the correct location. So I'll hit save. It saves this as a library feature part, LFP, and you'll know it's successful when you see the sketch with an L next to it. That means it's successfully converted to a library feature part. So there's my sketch that's captured. I still have my configuration information in there, and now it's ready to be used. So I'm going to save it one more time, and let's just create a new path that we can then call our new lumber profile. So I like creating rectangles. I'll just create a rectangle as a path. And then under my weldments, when I go to structural member, I should have created that folder called lumber, where I can now access the lumber folder. And then under the type, I will now have my softwood that I just created. And since it has been configured, I have access to both the 2x4 and 2x6 sizes that I created. So let's go ahead and call the 2x4, and I can just go ahead and start selecting edges. And there's my 2x4, just following the edge. Now, I mentioned those construction lines. So if you ever do want to locate the profile, down here under Locate Profile, you can go and pick any of those construction edges to then use as the guiding part or guiding point that's going to follow the path. And you can also change this to be different angles. So there's my 2x4, and I can go ahead and select additional edges for, say I'm making a 2x4 box here. Hit the green check, and there's my custom profile now for my softwood in my 2x4. And if I wanted to go back to Edit Feature, I can always change it to a 2x6. My profile will update, and I have multiple sizes all now contained in my new profile. So I do want to take this a step further because there's additional information to make our lives easier down the line that we can contain inside the custom profile. So I'll go ahead and close this. We'll go back to our custom profile. And one of the things that we can contain inside the custom profile is we can actually carry with it a material. So in this case, it's a softwood. We can go into our materials, and I've already found it earlier, but there's inside the woods folder for the materials, there's a cedar. So a very common material, we can just apply it. Now, since this is just a 2D sketch, we don't see the cedar take effect, but that information is now contained inside our Weldment profile. So I'll go ahead and save it. I'm going to go ahead and create another configuration as well, so we'll just add some additional information in here. Let's create a 2x8 as well. So I'm just adding additional information to my profile, so you can have more than one configuration, more than two configurations. So this should be 7.5 inches. Apply and OK. So I've got multiple configurations. I've got a material. And then the last thing that we can also utilize are custom or configuration-specific properties. So in this case, what I can do is I'm going to apply this to the 2x4 configuration first, and I'll add a description, and that description will read 2x4 lumber as the description. And then I can go to the 2x6 and do the same thing, description 2x6 lumber, and then finally the 2x8. And this one will be 2x8 lumber. So now I have my configuration-specific descriptions. And those will be carried through on my Weldment profile as well. So I'll go ahead and save it. I'm done with this for now, so I'm going to close it. And then let's use our new profile. So again, sticking with rectangles because I do like drawing rectangles. We'll go back into Weldments, and we'll call our new profile. So lumber, softwood. Notice I have 2x4, 2x6, and 2x8 available. So we can say 2x6. And then right below that will be a checkbox for transfer material from profile. So because I created the cedar material inside the profile, that will come through now directly to my part. So there's my 2x6. We'll go ahead and say 90 degrees. Maybe I'm making a garden box for my 2x6s, and I'll hit OK. So there's my wood material. I can go ahead and see it with real view. With my 2x6, the material already came over. And if I look inside my cut list, and if I look at the properties, the description value of 2x6 lumber came as well. So if I wanted to go back now and change this to a 2x8 size, inside my description properties, I now have 2x8 lumber. So utilizing your custom profiles, you can carry that information with it. So in this case, I'm going to show you one more trick or one more tip for this topic, and that's if you want to see your description values populated in the cut list. So check out these options if you haven't. Inside your options, you're going to find this option under your document properties, so this is saved per document. There's a lot of Weldment-specific options that you can set. And one of those is rename cut list folders with your description value. So with that checked, automatically my cut list is listed as 2x8 lumber. And if I wanted to go back to my configurations and just say 2x4, it updates the profile, updates the material, and updates the description value, which now populates through to my cut list. So all of that information you can save per custom profile. Like I said, you're not going to get everything inside the default libraries, but check out those additional libraries and install them. And by install, I just mean save them to the correct location. And that correct location, it can be found in your system options. You can also point it to your server location if you want, or anywhere else on your hard drive. So just be aware that it does capture, for the profiles, it does capture your configuration information so you can change dimensions, descriptions, and materials, all saved within the custom profiles. Just make sure you do save it as a library feature part when you do. Pre-select the sketch, very important parts when creating your own custom profiles. So that leads me to my last topic. My last topic is what I consider advanced, and that's what to do when you have non-standard miters. So in this case, what I have is a very unique miter, essentially, and it's a curved miter. So it's where you have something that's non-45. They don't exactly meet in a traditional way. So you have to create your own end condition or your own trim. So that's what I'm going to do inside SOLIDWORKS. So I'll go ahead and close this part. And what I'm going to do is actually open up a file that I have a path already generated. So this is my path. It's just a sketch. So I'll go ahead and now convert this to a weldment. And the weldment I'm going to use is a custom weldment profile that I made for molding. So I have a custom molding, and there's a couple different sizes, so I'll use custom one. I'll bring in the material for this one. And I'll go ahead and just start choosing some edges. Now I'll locate my profile for my custom molding and choose some additional edges. Now you'll notice with my second edge, that is a traditional 45 degree, so it miters it, or 90 degrees, so it's a 45 degree miter, which it does really well. And if I choose my next curved segment, Weldment actually handles that one really well also. But you'll notice down here I don't have a traditional 90 degree. So if I go ahead and choose this, SOLIDWORKS will create that 45-degree miter. And if I create it, in this case, if I look at the area where it meets up, that is not a very clean miter. And if I look at the back, it becomes a little more obvious where those just don't match up right. So I'm going to have to go through and create my own miter, essentially. So there's a few ways I can do that. This is a trick that you're definitely going to use if you ever do have to create your own trims. So in this case, what I'm going to do is edit my feature. And what I want to do is exclude this from my automatic trim. So the way I'm going to do that is I'm going to select it and remove it from my current group. And then I'm going to select New Group and then start a new group for my next portion. And I'll go ahead and locate the profile for this one to make sure it's in the correct spot. So now I've got two different groups. Now what that does is it doesn't automatically trim it for me, and that's how I want it because I'm going to go through and create my own trim. So there's my two weldment bodies. They are currently intersecting. So what I need to do now is create my own miter where those 2 points meet. So I'm going to do that just via a traditional cut. Now if I go, I'm going to try to sketch the line where I want to create the cut. And if I draw a straight line through my part, I can see that the straight line doesn't exactly match the contour of where my two weldment structures meet. And that's why the traditional miter isn't really working. So the reason is because this is a curved miter, the natural intersection mimics an arc more than a line. So what I'm going to do is use the 3-point arc command. The 3-point arc command, if you haven't used it, you choose the first point of the arc, then the end point of the arc, and then your radius. So I know where my arc starts, I know where it ends, and you'll notice as I get closer to the natural curvature that it really mimics an arc a lot better than a line. So I don't really have anything to snap to, so I can't really snap it, so I'll arbitrarily place it out to the side because I'm going to introduce the next tip. And the next tip we have is a sketch command, and what it allows us to do is create a virtual sharp. So what a virtual sharp is a point where two edges or lines intersect. So in this case, what I can do is control select two model edges. And if I use the sketch point command, it is then going to create a virtual sharp at the intersection of those two edges, which I can then use to make coincident to my arc to lock my arc in on the correct curvature. So that was virtual sharp. It is a sketch command. If you have two entities selected that intersect each other, so two lines, two edges, it will create a virtual sharp, a point that you can snap to. So my arc is then snapped to that point. So if I look at it from a different view, there's my arc that has the natural curvature. Now I just need to make sure that I cut along that line. So if you didn't know you could do this, even a sketch line is enough to create an extruded cut. So I'm going to take my one single sketch line here, and I'm going to access my extruded cut command. Now when you do an extruded cut command on a line, what SOLIDWORKS is doing is I'm going to use my end condition as through all both. It's assuming you want to cut everything above and below that line. And because it's just a single line, it's cutting everything above and below, so there's my preview. I can also choose to cut everything to the left of that line or to the right of that line. So right now the arrow is pointing to the left. Everything to the left of that line is going to get deleted. So if I hit OK, it does exactly that. And everything to the left of the line is deleted. So that worked great, but I kind of got rid of a little bit more than I should have. So there's an extra body here that I didn't really want to cut. I got this one right, but not that one. So this is going to be the last tip that I have for you as far as weldments go, and this is a great tip to use because it's specific to multi-bodied parts. And that's great for weldments because that's exactly what weldments are. They are multi-bodied parts. So anytime you're dealing with a weldment or a multi-bodied part, whenever you create a feature, if you scroll to the bottom of that feature, you're going to have a category called feature scope. So inside the feature scope, you can actually choose which bodies you would like that feature to affect. So in this case, I only want to cut this body, and I want to leave the other one alone. So I'll cut just that body, and it'll cut just that body, leaving the other one untouched. So now I can use that same sketch line and do the same operation on the other body. But I don't see my sketch anymore. So I'm going to reuse my sketch. Even though it's been consumed, I can reuse the sketch. So I'll take sketch 3 again and do another extruded cut. I'll do through all. And I'm just going to flip everything to the right side now. But instead of just hitting OK, I'm going to go down to selected bodies, and I'm going to uncheck the auto select. So that'll allow me to go in and say I want SOLIDWORKS to only cut that body, everything to the right-hand side of the line. Hit OK. And there is now my miter. And if I look up close, that is the correct miter to use. I can see that everything lines up all nice and neat. So that was my last tip. For anything that is non-standard, you'll probably have to go in and create your own trim or end conditions, but just by using extruded cuts. So if you do, just be aware there is the virtual sharp command. So that is a sketch command. If you select 2 lines or 2 edges, use the point command, and that invokes the virtual sharp. And then finally, on the extruded cut, I did reuse that sketch multiple times. So if you do use a sketch over and over, you'll see the little hand icon underneath the sketch, which means it is a shared sketch, so it's being used for multiple features. And then very specific or very useful in weldments, if you have multiple bodies, so multi-bodied parts specific to weldments, you have a feature scope. So you can choose which bodies you're creating your end cuts on. And this works for many features, not just the extruded cut. So just be aware when you have multi-bodies, you also have a feature scope inside your features. So that's everything I have for you. Like I said, a beginner, an intermediate, and advanced tip. Hopefully everybody picked up at least one thing. If you learned, if you didn't know anything about weldments, hopefully you feel a lot more comfortable with weldments. But that's everything I have for you today. I hope you learned something, and thanks for coming.